There's your squeeze bottle, your squirt bottle. I'll put this down a little lower so you don't get it all over. Good job, Alex.
Washing off that orange juice, that looks pretty good right now.
Yeah. Okay, I think you got it. Want me to give it a little extra shot? I think you got it. I trust you. You've even got pretty good technique. And a lot of science is technique. So let's get the half and half. Doing half and half. Yeah, say half and half.
That looks good.
Okay, I didn't have any milk. The milk I had to throw out today because it was kind of spoiled. You know, so well, that's good. You're in there good enough.
Okay, 6 points.
Milk. It's got less hydrogen. It's going towards the basic instead of acid. It's looking
Water is
basic.
going to be very high.
Yeah. Yeah. That's interesting, huh? What do we got? It's almost, they call it neutral. They say milk is neutral because it's so close to 7. In the middle of the scale for pH is 0, very strong acid, burn your face, all the way up to 7, which is neutral, like water, almost like milk, and then you go to 14. It goes 0 to 14. When you get to 14, very strong base. That'll burn your face too. When you get to the extremes, it can give you a chemical.
You can't go too high or too low.
No, you want to stay towards in the middle. But in your stomach, you have hydrochloric acid. That's very strong. You have special cells in your stomach that can handle strong acid. Okay.
We didn't have that.
Okay. But these are simple organic acids. These are coming typically from. Okay, so I'm figuring 6.92 for half.
Wait, is that the right one?
Yeah, I put it.
Oh yeah.
I was a little out of order. My good catch though, Alex. Okay, so let's lift that up and out, and you put that to the side.
I want to drink it.
Yeah, no, it's cream, huh? Now, we don't. One thing about science experiments, it's never a good idea to put them in your mouth when you're going. Even if they're just food products that didn't really do much. God.
Oh, there's a lot of milk on it.
Yeah, yeah. And this probe is a very special probe, Clara. It has. It's designed for food products.
Wait, it can do other things too, right?
Yeah, yeah.
But
there's other ones that are better for certain things. Like you get different detectors and probes that are specific for certain products. This one is a general, safe one for schools. Okay.
Okay.
Yeah, I'm just gonna hit that one last time.
Oh, it's 7. There's no acid.
Yeah. No, because the water is 7.
7 to 7.
Okay, so now what we're gonna do is.
Oh, it's actually going down. Okay.
Once you get the coffee, if we're gonna have coffee, if we're gonna have half and half, we need our coffee, right?
Mhm.
Right? We need some coffee.
Well, the coffee needs the half and half.
Yeah.
Not the half and half.
Okay, guys, let's see if this is acidic. I think we're gonna go the other way now. We should have done the coffee first, right? That's why I had the coffee here. We grabbed the wrong one. That's okay. But we're going back down now. See how the going down? I'm gonna say 5.6. 5.6. Where are we going to? That's 5.5. So coffee is acidic, right?
Acid. Acid.
So adults drink a lot of coffee, and maybe it's wearing away their teeth because acids will dissolve bone.
Just a little, right?
Yeah.
Not that much.
Right.
But if you eat like
over time,
500 gallons a day of coffee, then do you think you would have lost probably 2?
What do you think? 5.50 stable? Okay.
Yeah, 5.50.
Okay. Let's pull that one out. That's a nice cup of Stop and Shop espresso. Pretty acidic. Okay, so let's move that out of the way. That one's done. Let's get this. Go ahead, go back up there and rinse it. You're the technician. You got a lot of kids you're gonna have to teach. I'd hit the top of it first. You know, that way everything goes down. And normally you don't want to get the tip to it. Good. Squeeze towards the middle. Squeeze towards the middle. It's easier.
Oops.
Don't worry about doing it, Alex. Just go from the top down. There you go. It'll run down on its own. There you go. Yeah. Yeah, just go like this. Yeah, like that. There you go. Then there you go. Okay, we got another one coming. Now.
Last one.
Let's go to. You want to do that one's got detergent. You want to do that one last? This, yeah, okay, that's tap water. You can do the tap water. Let's do the tap water.
This is tap water?
Yep, tap water, right from Guilford, Connecticut tap.
Hard to tell both of these.
Yeah, well, we're going to fill this one up with seltzer.
Oh.
Okay, this is tap water from Guilford, right here, right at our sink. Connecticut Water Company is what it is. This should come pretty close to 7 all on its own.
Maybe we don't need to wash it because it's water.
Right, we'll leave that one. There's no point in washing that one, right? Okay, so here is, it's coming up.
6 points.
It's going to take a minute or two. Sometimes you can go like this and
Oh yeah, it's probably going to go maybe near 7. Oh, wait, it just dropped down.
Yeah. Notice the temperature is 62 degrees at water. Everyone's at a slightly different temperature, but they're close. This is kind of like room temperature, 62 degrees Fahrenheit. And the probe is being corrected for by the temperature. Because pH, how much hydrogen is measurable in water or in a liquid, is also changed by what the temperature is. The warmer the temperature, the colder the temperature can change how much hydrogen is available. So we're basically losing hydrogen in these solutions as we go up. We went out of order a little bit, but overall, yep. So this one is still going. Okay, I think this one is around. Should get up around 7. I'm gonna kind of help it out a little bit. Oh, didn't like that. There we go. Okay. There we go. Yeah, it's almost up to 7.
67, 68, 69,
Yep.
70, 71.
And that's the hundredths place, right? 3. Oh. Oh.
76, 77, 78, 79, 80, 81.
Hey, why don't you pour? Get the seltzer one. Get the seltzer one ready to go.
Okay.
Because we're coming down to the end here. Again, Stop and Shop. A lot of these products are Stop and Shop right here from Branford, Connecticut. Go up to the white mark in the shot glass. There you go. It's going to be interesting. I bet you that seltzer water is a little acidic. You can take a sip of the can. Yeah. Want a little sip, didn't you? Is that thirsty? Oh, that's some good stuff there. Huh? Yeah, so the School of Natural Sciences. So while that thing is still equilibrating, we're going to come over here and talk about...
it's stable.
Is it stable?
Actually, no, it's still moving.
Oh, that's cool.
It says stable, but
so we're doing pHs of liquids. And you got water going over to hydrogen and hydroxide. And if you had a flask, you'd have some things that are going either way.
Oh, we're still moving.
Yeah. I think it's going to probably equilibrate right around 7.
Okay, wait. I think it might.
Yeah, you can take that value. Yeah, I remember earlier when I checked, it was around 7. So, what do you think, Clara? We got one more to go. That last one we have is a detergent we use for the sink. I forgot the brand of it. Remember our branded detergent? It's one they use to clean oil off animals. Clara. What do you think that last one's going to be? Is it going to be very basic, going up way above 7?
707.
Yeah, it's a cleaner. It's a detergent. A lot of detergents are high in pH.
It's not water. Is it? Water?
Yeah, that's water. Yeah. Okay. All right. So let's go with 7.1. How about that? Go for
wait. I think it might. 710. Just do 710.
Yeah, we'll go 7.10. 7.1.
7.11.
We're going.
7.12.
Okay, measure the seltzer. Now let's see where the seltzer goes. Here, take the seltzer water. You don't even need to rinse it. Right here. Here's your seltzer water.
Yay.
There you go.
The fizz, the fizziest of the fizz.
Okay.
Oh.
Oh, yeah, it dropped down. See? It's
Going
going down.
down.
Seltzer water is acidic. Has more hydrogen than tap water. Tap water has less hydrogen. Okay. Tap water is more neutral. Seltzer water is more acidic. It's kind of like a Coca-Cola or one of those. We didn't do Coke, but Coke would have been around 3 and 4 too. Coca-Cola, anything that's
Coke's good.
Yeah, usually using the carbonated beverages are low. When you add CO2 to water, it makes it a little bit acidic. Okay. So let me know when that's stabilized. I'll put the value down for seltzer. I'm figuring 4.10. Yeah, okay. 4.10. We'll take the measurement there. Now we got one last one. The reason why I'm finishing up this one, because this has a cleaning solution. It's like the stuff we squirt for dishwashing liquid. Okay?
Oh, it's wait the...
Yeah, it'll clean everything up.
Wait, it looks lighter though.
Yeah, it's one drop off the bottle into, this is like 2 ounces of liquid. Okay? Now watch what happens to that pH now.
Up.
What's it doing?
Going up.
Yeah, going up pretty fast. Right? It's going up fast. Yep.
Instead of 1 at a time, it's going.
Yeah, give it
it's
a little
going
bit of
2 or 3 at a time.
Yeah, let's give it a little bit of a shake there. Kind of help it out.
Oh my
There we
gosh!
go.
It jumped from like
Yeah, because
17
it's
to 9.
the detergent's getting up in there. The liquid detergent's getting. Give it another little swirl, Alex. A lot of times they use the magnetic stir bar thing for this, but we don't have one in there. Go, give it a little motion. There you go. That helps kind of just get those. Okay, so these have more OHs. Right, so when you look into a solution, it's either got H plus. See up on the chart, H plus or OH. See on the board there. Okay, so this detergent solution has way more OH than it does H plus, so it's more basic. And that's about where it'll go a little higher, but it's 8.5. It goes into 9. It'll probably go right out of calibration. Yeah, it says out of calibration, but it's pretty accurate. We know it's a very high solution of hydroxide, so there's more OH negative than there is H plus. Okay, so let's call it 8.63.
Out of calibration range.
Yeah, because we didn't put a point that high, so they're just warning us, which is great.
Out of calibration range.
Okay, all right, so I think that's it, and we'll just clean up, and that'll be our science experiment today. I think we got about done 20 minutes of video. Yeah, I think we're all done. Clara, thank you very much. Papa says thank you, everybody. Scientist and photographer ClaraMelody Arpey, technician Alexander Arpey, and what am I, the instructor?
Well, I'm out of here.
All right, thank you.